Hello everyone, this is John Hashmatad. Welcome to Physics Simply. In this video I will be solving some questions in multiple choice about astrophysics or space physics. I placed a link in the description for the PDF file for these questions for you. The first question says, which row in the table correctly lists a galaxy, a planet, and a star? So the Milky Way is a galaxy, the solar system is not a galaxy, it's a cluster of planets around a star in the middle of the Milky Way. Mars, Earth, all these are planets. A star is the sun, not the moon. So the answer is B. The second question says the orbit around the sun of a comet is not circular. The distance between the sun and the comet varies as shown in the diagram. Where in the orbit is the speed of the comet the greatest and where is it the smallest? So the comet speeds up as it gets closer to the sun and slows down as it goes away from the sun. So highest speed is at R and lowest speed is at P. So greatest speed R, lowest speed P. So the answer is D. The next question says the orbit around the sun of a particular asteroid is not circular. The distance between the sun and the asteroid varies as shown in the diagram. The asteroid possesses both gravitational energy and kinetic energy. So which energy transfer takes place as the asteroid moves from X to Y and from Y to Z? Okay, from X to Y, it's getting closer to the sun, so it's losing GPE. Same as height from the sun decreases, so as height decreases, GPE decreases, and kinetic energy increases. So from GPE to kinetic energy. And from Y to Z, it's also losing height and getting closer to the sun, so it's also losing GPE and gaining kinetic energy. So the answer is A. Question 4 says, Ceres and Vesta are two asteroids or dwarf planets that orbit the sun. The orbits of Ceres and Vesta are approximately circular. The sun's gravitational field at the orbit of Ceres is weaker than that of the orbit of Vesta. So if this is the sun, Ceres is actually further away from the sun since the gravitational field strength of the sun at Ceres is weaker. That means it's further away from the sun, and Vesta is closer. How does the orbital speed of Ceres and its orbit period compare with the orbital speed and orbit period of Vesta? So as you get closer to the sun, the speed of motion increases. So here the speed is higher than at Ceres. And so the periodic time here is less than the periodic time at Ceres. So the orbital speed of Ceres is smaller than that of Vesta because it's further away. And the orbit period of Ceres is greater than of Vesta because it's still also further away from the sun. So the answer is B. The next question says the sun emits energy in the form of electromagnetic radiation. Which three components of the electromagnetic spectrum account for almost all of this energy? So most of the energy emitted from the sun is in a range of visible light, ultraviolet, and infrared. So it's not microwaves, infrared, ultraviolet, and visible light, yes. So the answer is C. The next question says, when in the life cycle of a star are heavy elements produced? When a cloud containing hydrogen collapses? No, this is the start of the life cycle. When a protostar becomes stable? No. When a red supergiant explodes? When a white dwarf is formed? Actually, it's C, because as the core collapses, it leaves behind the elements that became fused together, making these heavy elements. Just before the explosion of the supernova, these heavy elements are present, and the supernova pushes it into space. The next question says the statements J, K, L, and M describe different stages in the life cycle of a star. A cloud containing hydrogen collapses due to gravitational attraction. A red giant is produced. A white dwarf is produced. Hydrogen undergoes nuclear fusion to produce helium. So at first we have the nebula, which is the hydrogen cloud, which then causes the fusion to start by attraction as gravitational pull pulls the atoms more close together. They gain speed and fusion starts, and eventually when the fusion of hydrogen ends and the helium fusion starts, a red giant is formed. And when all fusion ends, a white dwarf is formed. This is for a low mass star. So we have J, M, K, then L. So the answer is A. The next question says, what provides evidence for the Big Bang theory? The expulsion of heavy elements into space during a supernova explosion? No. The increase in the observed wavelength of radiation emitted by distant galaxies? The increase in wavelength means a lower frequency. That is called red shift. So actually this is the answer. The nuclear fusion reaction that takes place at the center of a stable star, it's not the evidence for the Big Bang theory. The smaller orbital speeds of the planets that are further from the sun, that means that the gravitational pull gets weaker as distance increases. It's not related to the Big Bang theory, so the answer is B. Here are some other questions from another file. The first question says, the diagrams represent the positions of the Earth, the Sun, and the Moon at different times of the moon cycle. Which diagram represents the position of the Moon when a full moon is seen from the Earth? So for a full moon, the total surface of the Moon must be illuminated, which means the Earth is actually in between the Moon and the Sun. So the answer is C. So all light coming from the sun, it falls on the surface of the moon and then reflects on the surface of the Earth. The next question says, which row correctly describes the nature of Mars and the nature of Saturn? So Mars is from the inner planets, so it's a rocky planet, and Saturn is from the outer planets, which are gas giants, so it's gaseous. So the answer is C. The next question says, which type of force keeps the planets in orbit around the sun? It's not electrical, it's not friction, it is the gravitational force, it's not magnetic, so the answer is C. The next question says, which distance is the largest? The diameter of Neptune's orbit, the diameter of the sun. The diameter of the sun is actually much smaller than the orbit of Neptune. The distance between the Earth and the sun is between these two values. The distance between the sun and the next nearest star, that's actually much further away than all of these choices. This is outside the solar system, so this is the largest one. Another question says, which statement is correct? A light year is the time it takes for light from the sun to reach the Earth. No, it's not time, it is the distance traveled by light in 1 year. B says, the planets move around the sun in circular orbit. No. It is not circular, it's elliptical. The sun consists mostly of helium. No, right now it is mainly hydrogen because it's a stable star at this stage. The sun contains most of the mass of the solar system. This statement is correct, so the answer is D. The next question says, the sun emits electromagnetic radiation. The graph shows the energy emitted per second for a range of different wavelengths. So we have most of the radiation is in the middle at Y, and the wavelength increases in this direction. So this is short wavelength, this is long wavelength. So the radiation which has the shortest wavelength emitted from the sun with high intensity, it is the ultraviolet. So X is ultraviolet, and the middle is visible light. And with the longest wavelength, we have infrared radiation, so the answer is C. The next question says, a distant star explodes as a supernova. Which statement is not correct? The exploding supernova forms a planetary nebula. The distant star is large when compared with the sun. The supernova releases heavy elements into space. The supernova leaves behind a neutron star or a black hole. Actually, the last one is correct. This one is also correct. A distant star is large when compared with the sun. Yes, because it causes a supernova. Supernova happens when the mass is much greater than the sun. So we are left with A. Technically, a supernova should have a planetary nebula around it, but it forms just before the supernova, and the supernova pushes it outwards into space. The last question says, the distant galaxies are moving away from the Earth at very high speeds. Graph P and graph Q show how the speed of these distant galaxies changes as their distance from the Earth increases. So according to Hubble's law, speed is equal to the Hubble constant multiplied by distance. So it's a straight line through the origin, since it's a direct relation between speed and distance, or relative speed and relative distance. In which row are statements about the Hubble constant and about the age of the universe correct? So the choices contain gradients and area under graph. So the gradient of the first graph P is equal to speed divided by distance, which is equal to the Hubble constant from this equation. The gradient here is equal to distance over speed, so it's equal to 1 over the Hubble constant. So these have opposite gradients. So how can we calculate the Hubble constant? It's a gradient of P, not Q, so it's either A or B. And the age of the universe can be calculated using the equation 1 over the Hubble constant. This is how you calculate the age of the universe in seconds. So this is actually the gradient of the graph Q, not the area under the graph Q, so the answer is B. Okay, this was the end of the video. I hope you found this video useful to you. For the exam today, I wish you all the best, and I hope you all do well in paper 2.